Okay, welcome back to physics. Today we're going to switch gears away from graphing and we're going to start using equations. And our first equation is going to be pretty simple. It's an equation you probably don't realize, but you have probably used in the past in your math class. And it's right here. And this is read, and it's going to be interesting to see how it's read, but this is read as delta x equals v times t. Okay, let's unpack that a little bit, because the first thing we have a problem with is this. What in the world is this? You probably don't have much experience with this symbol right here. That symbol right there, that's called a delta. It's actually a Greek letter. It's a capital D, stands for delta. Well, great. What does delta mean? Delta simply means a change in something. So in this case, since we know what x stands for, right? We defined x in some earlier notes. We know x stands for position. We know that delta x is simply just a change in position. So, for example, if I were to ask you what's your position right now and you're watching this video from your home, you might say, my position is sitting at my kitchen table at my house. That's great. Now I know where you're located. But then if you get up and let's say you walk 25 feet to the left of the table, I would ask you, well, what's your change in position? How has your position changed from your original spot? And you say, well, my position has changed by 25 meters to the left. Okay, so your change in position, even though you walk 25 meters or feet, whatever we said, 25 feet to the left, and now you're in, say, the living room, that's not what we asked. Your original position was the kitchen. Your new position is the living room, but your change in position is 25 meters to the left. So that's what that delta x stands for. It stands for change in position. The other variables you could probably figure out on your own. V stands for velocity. I think we've talked about that before. And T stands for time. Now you have to be careful because you want to make sure your units always match up. So for instance, if we're measuring velocity in meters per second, that means our change in position will be measured in meters and our time will be in seconds. So if we were to give you, say, your velocity in meters per second, but your time in hours, you'd have to do some conversions in order to accurately calculate your change in position. Okay, so we'll get to that. I'm just giving you a little spoiler, right? Now let's talk about what this triangle right here means. I'm personally not a huge fan of the triangle, but if you struggle a whole bunch in algebra, this triangle might be for you. So the way the triangle works is that it allows you to solve for any of the variables in relation to the other variables. So for instance, if I wanted to solve for delta x, you might put your thumb over the delta x, and then you would realize that delta x is equal to what's left. It's just v times t, because the v is next to the t, right? The v is next to the t, so they're going to multiply. Well, what if I instead wanted to solve for velocity? Well, I would put my thumb over velocity, and I would see the velocity is equal to delta x divided by t, because when I cover up velocity, the delta x is on top of the t. And if I wanted to solve for time, I would cover up the t, and I would say, well, time must be delta x over velocity. Okay? So you can use the triangle if you like. But I will tell you that on any quiz or test, and this is for me, Mrs. Van Hoy in particular, most other teachers will follow along, the only thing I'm going to give you on an equation sheet is this equation right here, okay? So you will have to figure out how you can solve this, or you just have to remember to write down this triangle on your test so that you can use it as a helper, okay? So let's go ahead, let's fill in our notes a little bit here. What does delta mean? Delta means change in. Some examples of when we will run into this in the future. We're going to see this a lot. We're going to use a lot of delta x. We're going to see change in velocity. We could see change in time, okay? So we're going to see this a lot. So just keep in mind that delta always just means change in whatever variable follows next, okay? So let's see how we're going to use this equation. Adriana walks at a constant speed and speed is basically the same as velocity. We haven't talked a lot about that, but speed and velocity are interchangeable for now. They're a little bit different. Velocity has a direction, but we don't have to worry about that right yet. So, Adriana walks with a constant velocity of 2 meters per second. She times herself with her phone and finds that it takes her exactly 10 minutes, which is 600 seconds. So we did the conversion for you. 10 minutes is the same as 600 seconds to get to school from her house. How far away from school does she live? So here's how we're going to do this problem, and I'm sure you guys are familiar with this from chemistry. The first thing we're going to do is we're going to write out a list of our variables, and we only know 3. We know delta x, we know velocity, and we know time. So we're going to go ahead and we're going to list those. And if we know them, we're going to fill them in. If we don't know them, we're going to put a question mark. So delta x, do we know anything about how far she traveled? We don't. Actually, that's what the question is asking. So I'm going to go ahead and I'm going to put a question mark for that because I don't know it. Do we know anything about velocity? Well, yes, we do. They told us in the problem that she knows she's walking at 2 meters per second. Do we know the time? We sure do. They told us in the problem that it's 600 seconds. So that's step 1. List my variables and fill in what I know. Step 2 is always to write down the equation I'm going to be using. People say, oh, how are you going to do this? Well, I'm going to solve for it. Well, what are you going to solve for? I'm going to solve for delta x. Well, then you better have an equation that has delta x in it. We only know one equation, so you're thinking, well, why do I have to write it down? Because pretty soon we're going to know lots of equations, and you're going to get lost if you don't write it down. So always write down your equation. Okay? So that's my equation in variable form. That was step 2. Step 3 is go ahead and plug in what I know. I don't know delta x, so I'm just going to leave it as delta x. I do know that the velocity is 2 meters per second, and I write that with my variables because I want to check and make sure my variables all work out. And I know the time, 600 seconds. Now, let's see what we did here. I wrote those variables for a reason because I know seconds on the bottom are going to cancel seconds on the top, and my answer is going to be left in meters. So now I can get my calculator out, but I think I can multiply 2 by 600 pretty easily and come up with 1,200 meters. So her house is 1,200 meters away from school. Well, wait a minute. We already told you that answer because we want to make sure that when you're doing these problems, if you get them wrong, you get the chance to go back and try them again. So handing this in, it makes 0 sense to just write down the answer that we already gave you. We're really looking at the work. Make sure you're doing quality work so that we know you understand the process and can do it. Okay? All right. Let's take a look at Michael Phelps here. Michael Phelps, he's a swimmer, if you don't know who Michael Phelps is, and he was really fast. I think I just saw somewhere on the news that someone just broke his last remaining world record. So good for them, and good for Michael for having so many. All right, so Michael Phelps won a gold medal in the 400 medley with a time of, 4 minutes, 12.48 seconds. And we went ahead and we did the conversion for you already. That's 252.48 seconds. What is Michael's average speed? And remember, speed and velocity are the same thing for this race. So we're going to do this problem the same way. We're going to list out delta x, velocity, and time, and we're going to plug in what we know. We know delta x because it's a 400-meter medley. So we know 400 meters. What velocity is he going? We don't know. That's what we're trying to find. And we do know the time. It took him 252.48 seconds. So I listed my variables. The next thing I have to do is write my equation. I only know one. Now, if you wanted to go ahead, well, we got to solve for velocity. If you wanted to write the equation this way because you were kind of using that triangle, that's fine. I just tend to always use the base equation that I've kind of memorized, and then I plug in what I know. So now I can say 400 meters is equal to V times 252.48 seconds. So velocity is 400 meters. Divided by 252.48 seconds. You can plug that in your calculator. When I plug that in my calculator, I got 1.58 meters per second. So I'm not entirely sure why we put the answer as 1.5 because that really rounds to 1.6. But we'll just go with it. And don't worry too much if you're just off by a rounding error. Go ahead and put a box around that too so I know that you got the right, so I can find the answer pretty quick. Okay? All right, one more here, again with Michael Phelps. If he can swim forever, it seems like a long time, but sure, why not? At the speed we calculated above, How much time would it take him to cross the English Channel? The English Channel is 33,800 meters wide. Why would he want to do that? I don't know, but maybe he's a crazy kind of guy. So delta x, v, and t. They told us that the English Channel was 33,800 meters wide. Now, how do I know that that's delta x? Maybe I don't, but I always take a look at the units. The units help me out. Meters. What do I measure in meters? I don't measure velocity in meters, right? If I were to ask you how fast you drove to school today, you wouldn't say, oh, the speed I drove was 1,000 meters or 1,000 miles. That'd be ridiculous, but 25 miles. You'd say 25 miles per hour, something like that. So meters I know is a length or a distance. And then the same thing with velocity. I know velocity is 1.58 meters per second. And I know that, and if I don't, then I use those units to help. The time is my question mark. Then I go ahead and I write my variables, 33,800. Oh, I want to do that differently. Hang on a second. I want to write my equation. Delta x is v times t. Then I can go ahead and I can plug in my variables. There we go. I know my velocity is 1.58 meters per second times time. I can do a little bit of algebra. I divide each side by 1.58 meters per second. Okay. When I do that, you'll notice the meters cancel out with each other. That's seconds because it's over will pop up to the top. And when I plug that into my calculator, I get 21,334 seconds. Oh, but wait, we gave you the answer in hours. Well, what a nice way to get us into conversions. Now I have to do a conversion. You will remember conversions because I bet last year in chemistry you spent a lot of time working with moles. Oh no, did I just scare you because I said moles? Don't worry, you used factor labeling, and we're going to use the same process here. So let's go ahead and let's do our first conversion. And let's convert these seconds into hours. So with factor labeling, our process works like this. We write down what we want to convert. I want to convert 21,334 seconds into hours. So I write that down. Then I multiply and I write a line. And on this line goes my conversion factor. I need to know something about seconds and hours so that I can get from seconds to hours. And maybe you do, and maybe you don't. But I'm betting you know how many seconds are in a minute. Hopefully you know that there are 60 seconds in 1 minute. So I go ahead and I write 60 seconds in 1 minute. And hopefully you see that I made a terrible mistake. What is that terrible mistake? These seconds will not cancel with these seconds because they're both on the top. I've got to flip this over so that the seconds here on the top will cancel with the seconds on the bottom. So I'm going to go ahead and erase this. I'll erase the whole thing. There we go. And I'm going to write 60 seconds in 1 minute. Then I can see that these seconds will cancel with these seconds, and after I do the math, I'll be left with the number of minutes, which is closer to hours, but not quite, so I've got to keep going. So I'm going to go ahead, and now I'm going to convert minutes to hours. And I happen to know how many minutes in an hour there are. There are 60 minutes in 1 hour. So let's think about this. 60 minutes in 1 hour. So 60 minutes is going to go one place, and the hour is going to go someplace else. Hopefully you realize that the 60 minutes goes down here and the 1 hour goes up here, because that way the minutes will cancel with the minutes and I'm only left with hours for my units. Now, since I have the correct units, I'm done with my conversion. I only have to do some math. So now I can take a look, and I know I'm going to multiply anything on top and I'm going to divide anything on the bottom. So I'm going to take 21,334 times 1 times 1. Hopefully you know you don't have to plug that in your calculator. Times 1 times 1. That's ridiculous. And I'm going to divide what I get by 60 and then by 60 again. When you plug that in your calculator, make sure you take this number divided by 60 divided by 60. If you say divided by 60 times 60, you're gonna get all kinds of badness. Okay, so watch your order of operations. So hopefully when you do that, you will see that your answer is about, better get my pen going, 5.9. I think I got 5.93. Whoever did the key got 5.94. That's okay. Hours. And that is how long it would take Michael Phelps to swim the English Channel. That seems like a really long time to swim, but I hope he has the best of luck if that's what he decides to do. Okay? So there is some conversion, our first conversion for today, but we're going to have more. But before we get to some more conversions, let's take a look and see some other problems. So these first couple problems are pretty simple. We'll do one and then I'd like you to do the rest. Okay, so this is just kind of a practice, a little warm-up, all right, because this is the hardest part. All physics problems pretty much end in a math problem. You're really good at the math problems. You've been practicing the math since you were in first grade, kindergarten, even younger maybe. So the math I'm not too worried about. We got to get to where we understand the physics, and this first part is the physics. So let's say you have a problem that says Sam went for a 3-mile walk and it took him 45 minutes. First thing you got to do is list out your variables and fill in what you know. So go ahead, pause the video, fill in what you know, then come back. Okay, hopefully you put that delta x is 3 miles. You can't use m to stand for miles. M stands for meters in our class. So if you have miles, you have to either write out miles or at least put mi. We don't know velocity, so hopefully you put a question mark. But we know the time is 45 minutes. No conversions yet, so you just fill that in, okay? That's all we want you to do here. You can do these next 4 problems just based on that. So go ahead, pause the video, do that now. We're going to go through it in class in the next day or so. All right, let's go back to some conversions. I'd like to do a couple with you, and then I'm going to let you guys work on some on your own, okay? So let's do a simple one, and then let's do a tougher one, because the simpler ones you have some experience doing, quite a bit of experience actually from chemistry, okay? So let's see here. We want to convert 45 miles into kilometers. And over here, we gave you a bunch of conversions. Some of these you might know. I'm betting you hopefully know that there's 12 inches in a foot. But you probably don't know that there's 5,280 feet in a mile. Hopefully you know there's 365 days in a year. There's 24 hours in a day. Hopefully you know these down here. But if you don't, just in case you panic, here's some information for you. Okay? So we're going to convert 45 miles into kilometers. So we're going to start just like we did in the last problem. And we're going to write 45 miles. That's what we want to convert. So then we've got our times on our little line, and we're going to do this all in one step. And now we've got to come up with a conversion that goes from miles to kilometers. So I'm going to go ahead and I'm going to look over here, and I see I've got a direct conversion. 1 mile is 1.609 kilometers. So 1 mile is 1.609 kilometers. Uh-oh, did you see I made the same mistake again? Boy, I better get this right. That is not correct. So I see that, no big deal. I just go ahead and I fix it. And I say, oh, well, wait a minute. 1 mile goes on the bottom, and 1.609 kilometers goes on the top. Then I can see that this mile cancels with this mile because one's on the top, one's on the bottom. And now it's just become a math problem. So now I'm going to go ahead and in my calculator, I'm going to plug in 45 times 1.6, and hopefully you see that you get 72.4 kilometers. Easy peasy, lemon squeezy. Okay. Let's go ahead. You know what? Why not? Let's do another one, and let's go ahead and do problem 6 together. And let's convert 360 meters into miles. So I'm going to write 360 meters, and I want to go from meters to miles. But when I look over here, I have miles to kilometers, and I have kilometers to meters, but I don't have miles to meters. So this is going to be a 2-step problem. So the first thing I'm going to do, since I have meters, is I'm going to look and I say, well, I see a conversion here that 1 kilometer is 1,000 meters. So I'm going to say that 1 kilometer is 1,000 meters. Now I see those meters canceled with meters, and I'm left with kilometers, which is great, but it's not miles. So I still have to keep going. So this is what I mean by 1 step. I'm not just going to write what that is, okay? I'm going to go ahead and I'm going to keep on going. So I look at this and I say, okay, 360 meters into miles. I've got kilometers, and I can see that 1 kilometer is, 1 mile is 1.609 kilometers. So I'm going to go ahead, 1.609 kilometers in 1 mile. Kilometers cancels with kilometers, and I'm going to be left with miles. So when I plug that into my calculator, I can already see I don't think I'm going to get 0.36 miles. Let's see what we get. I got 0.22 miles. Put a little box around that, call it done. So that's no good. We'll fix that. Maybe it's fixed already in on your sheet. Maybe it's just on mine, okay? Jesus fucking Christ, this person. Okay, let's try a tougher one. Let's go ahead down and let's take a look at problem 10. Problem 10 says convert 80 miles per hour into feet per minute, inches per second, and kilometers per day. We give you the answer for feet per minute. So let's go ahead and try that. Let's make sure that that's right, okay? I've got 80 miles per hour. Now, the first thing I need to tell you is that there's a right way and a wrong way to write miles per hour. Really, anything per anything. And if you're writing it like this, with this slash per hour, you have no chance of ever doing a conversion problem like this correctly. I'm sorry, but you just don't. So you can't do it. Okay, please get rid of the slash. Never use the slash. The problem with it is that you can't tell by looking at that whether the hour is on the top or the bottom. So now you can't use your factor labeling method, and you're in for a world of hurt. So do not use the slash. Write 80 miles per just means that straight line, and anything after the per goes down below the straight line. The problem is, to get it into feet per minute, we have to convert the miles into feet and the hours into minutes. So we've got a lot going on here, and this is new. You probably didn't do this in chemistry. So please make sure you're following along closely here. So let's worry about the top first. And we're going to do this all in one step. Let's worry about the top, and let's get from miles to feet. So let's look back up at our table here. Do we have a conversion from miles to feet? Well, we sure do. 1 mile is 5,280 feet. So I can go back down here, and I can put in 1 mile. Oh, that's not going to work. There we go. 1 mile is 5,280 feet. Now notice miles on top, miles on bottom. Okay? Now I'm left with feet per hour. Well, I'm close. I wanted feet per minute, so I'm close. Now I have to get rid of this hour, and I've got to convert that hour into minutes. Luckily, I know, I'm going to go with the right color here. Luckily, I know a conversion that will get me from hours to minutes, because I know that in 1 hour, there are 60 minutes. And I put the hour on top because I already had an hour on bottom. So now those hours cancel with hours. And when I look at what units are left, I can see that I'm left with feet per minute, which is exactly what I wanted. So now it becomes just a math problem. So now I can go ahead. Oh, I'm not very good at remembering to switch over to the pen. So now I can go ahead and I can say, okay, I'm going to plug in 80 times 5,280 times 1, don't need the 1, divided by, there's a 1 out here implied, divided by 1, you don't need to put that in your calculator, and then divided by 60. So put that into your calculator, and you should find that your answer, whoa, that's really aggressive, that your answer is 7,040 feet per minute. Now what I want you to try, that we'll check in class at some point, or I'll post a key, I'm not sure what I'm going to do yet, is convert this 80 miles per hour into inches per second. You have all the conversions you need, and then try kilometers per day. So you're going to use the same process. Try that. If you struggle, well, let me know. The rest of this worksheets, and there are several more sheets in our packet, the rest of this worksheet, so part 3 and on, you should now be able to do on your own. There's a beginner level questions that are pretty simple and straightforward. Everybody should be able to get those. Then there are some intermediate questions that are a little bit tougher. So if you struggle with those, ask some questions in class. And then there's some expert questions, advanced. If you don't feel like you can get those, at least list out the variables and set it up. And then if you're struggling, we can talk about that in class. Okay, but everybody should get the beginner. Everybody should try the intermediate. And if if you're pretty solid and you're like, yeah, I'm ready for a challenge, go ahead and try those advanced as well. All right, thanks for watching. See you in class.